Okay, question number 21. So two parallel wires are parallel to the perpendicular to the bridge. Okay, there are two parallel wires over here. Two wire carries equal currents in opposite directions. Point S is the same distance only both the wires. So this distance and this distance are equal. Let me call this as R. Let me call this as R here. What is the direction of the magnetic field at point S? So what do? You need to find out what is the magnetic field at point S due to both the thing, and then find out what is the resultant direction. So with respect to this one, when you keep your magnetic field using your right hand thumb rule, you observe you can draw a circle here with this as your radius, right? So this will be the circle drawn here, and this would be your magnetic field. This would be your magnetic field due to this, and due to this one, this would be the circle. This would be the circle, and how will the magnetic field be? Magnetic field would look like this. Would look like this. Look like this, right? So the magnetic field lines are going like this over here. So if you have one line like this, if you have one magnetic field line like this, they have other magnetic field line like this, then what can happen? If they are equal distance over here, then this field line will be equal to this field line. So thus the component of this field line, let us say if I take this angle as theta, and this is magnetic field B, then along this direction it will be B cos theta, right? And along this direction it will be B sin theta. And similarly, if this is also B, then this would be B cos theta, and this is also B sin theta. So what will happen now? The vertical components gets added up while the horizontal components cancel each other. So there is no net magnetic field along the x-axis. There is only a magnetic field along the y-axis, right? So therefore, A is the right option. Okay, let us move on to the next one.